So I will be taking us through understanding retrieval augmented generation RAG. From now on, I can be saying RAG. When I say RAG, just know that I'm not talking about the RAG that you used to at home or the one you used to clean your tools at home and all of that. So I'll be saying RAG instead of saying retrieval augmented generation. So this is me. I'm Rashid Mudasiru, and a bit of me is what the our moderator just read out. I graduated as a computer science student, and I'm a Google Cloud developer expert in the Google Cloud platform aspect of cloud. In I do DevOps as my day-to-day job, and then if you want to see me on GitHub, on Twitter, which is called X, you can try to search Taurash. That's the name you are seeing on the screen. Okay, so this is what we'll be talking about today. Uh, we'll be talking about introduction to LLMs and the challenges we are facing uh, working with LLMs, and then we'll talk about how RAG can to solve that particular of LLMs, and then we do a deep dive into RAG completely, and then we'll do a couple of demos to see how we can build one and how to interact with the one that has been built before now. Okay, so that's the our to-do list for today, and then I believe with the time given to me, I should be able to cover a lot of things, and then we should be able to learn together. Okay, so beginning from the beginning or starting from the starting, let's understand what AI is all about. Okay, so when they say AI, what does it mean? Everybody knows that, but then I decided to come with a mathematical formula or a mathematical model for us to understand how AI work behind this scene. Okay, so for any type of AI system that you're interacting with, you have to provide a so-called an input, and that input is what will be passed to a particular model, and the model will generate an output for you. And then when we take it back to the LLM side of things, they will tell you come with a prompt, and then you take it to that particular LLM model, and the model decided to give you a response as an answer to what you're asking or whatever thing you are doing. Okay, so that's basically a rundown of how AI generally works. You have an input coming to a particular model built by an engineer, the people that built it, and the engineers and data scientists and all of those stuff. So they build a model. Your own is to come to that particular model, put your input, and then you get a response out of it. An example of such model is Gemini, okay, which is built at Google. Like Google did my team, they research on it, and then they come up with something that you can give an input to and you get an output out of it. Just ignore those epoch or those learning rates. Those are the words they use in the world of AI and machine learning generally. So when we talk of these LLMs, or when we talk of LLMs general, what they do is they are data driven. Remember, when I say LLMs, I'm referring to a subset of AI which comes out of the mathematical model that I just showed us just now. Okay, so when we talk about them, the key concept that we need to know about them is that the first of things that need to be taken care of is data driven. All of AI, all of LLMs, all of them, they are data driven. They need data to be able to do whatever things we want them to do. They are they request data from user, from anywhere, from different data sources to be able to do a lot of things. And then apart from that, they can help us to automate our stuff. They help in automation. They can do prediction, and as well, they can do generation. The case of generation is when you have to generate code out of a particular prompt that you provide, or you have to generate images out of the prompt you put into a machine. Okay, so in that case, we can talk about different things. We talk about multimodal model where you can generate text, you can generate image, you can generate videos. I believe our previous speaker must have spoken, to dwell more or share more light on what multimodal or something like that is all about. So you can with a single prompt, you can get different response in video, text, images, music, and all. Let's move forward. Okay. So when we move away from AI as a whole, we can say, oh, let's go into a subset of AI. A subset of AI is generative AI. Okay, so it's a subset of artificial intelligence, and basic focus of this particular thing is to generate content out of text provided or image provided or even video provided. You provide a video, you get a response, either a video response. You provide a text, you can get image response as the model is being designed to be. Okay, so it works based on your input, give you a response out of it. The reason why we need to understand it is this is the basis of what we want to talk about, the RAG as a whole. So it's important for us to understand how this thing works or what do they mean before we dive deep into the whole of RAG. Okay, so when we talk of generative AI, example is text generation, we have image generation and art generation, we have video generation, we have audio generation. You can use them to generate code as well. For instance, when we talk of LLMs, which is part of generative AI, you come with your prompts, that thing that you put into ChatGPT or Gemini or wherever tool that you want to use to expect a response is what we call a prompt. Then you expect to get a response, the answer you get from that particular model. Okay, how does this work? The basic analogy or basic explanation to this is that you use autocorrect on your keyboard when you start typing something to help you to complete it. Same way, these models, LLMs model work. They help you to complete what you want to do. They are just an auto completion to help you complete that thing that you put as a prompt. Okay, so but then the way they did it is a little bit different from ordinary autocorrect. Okay, the way they do their one is, oh, they do a kind of probability behind the scene to find what is more accurate to what you're asking, what is more accurate to complete your prompt. That's basically what they are doing. Okay, so if you put LLM is, it will calculate, do the mathematics calculation on thousands of data that is being trained on, and then pick one out of these thousands and help you to plug in to your response. Okay, so look at this particular one. So, this LLM wants to help us to generate code, and then we start with a, a for that we used to write a for loop in whatever programming language you're writing. This looks like JavaScript, yeah. Okay, so it helps you complete it. The highlighted part is the completion that comes with LLM, and then it will continue the completion like that till you have a full code that you are requesting for. Okay, so that's basically how LLMs work. They help you from your prompt to complete whatever you come with as your prompt. Okay, so when you provide a prompt and then you expect a completion, which is the response that you are expecting, at some point, LLMs may provide you a wrong answer. You may get answer that does not relate with your question. So why does that happen? When that happens, we call it hallucinations. Okay, when hallucination happen and what causes hallucination to happen, we'll talk about it, and then we'll now provide drag as a solution to that. Okay, so hallucination is when LLM generates incorrect or irrelevant answers for you. That's what we refer to as an hallucination. Okay, what causes hallucination? Number one thing is limitation in the training data. Okay, we all remember when Google released Google AI overview on browser, how people started tweeting online, posting it online that, oh, this thing is giving us wrong answer. If you can read the pictures there, okay, if somebody has how many rocks shall I hit or can I hit or something like that, and you say, up, you can hit at least one small rock per day. You can see how wrong that could be, how wrong that advice can be, telling you that you can hit rock. That's very wrong, and that's how LLMs can react. From one of the reasons for them to react like that is limitation in the training data. They are not trained on a data that can provide that kind of request or that kind of question that you're asking. Number two is lack of context. They don't know what you are referring to. They don't know the field you are talking about. So giving you the right answer is a problem for them because they lack context. And lastly, if you provide a complex prompt for your AI model, you may end up getting an answer that is like this, which we call an hallucination. Okay, we've now seen this to be a problem. It's now left for us to come up with solution to this particular problem. Okay, so people start to tell you that, oh, if you want to get the right answer, you need to go and learn prompt engineering. If you learn the prompt engineering very well, you can end up getting the right answer from your LLM system. And that is true. You can leverage on that, try that out. And at the end of the day, if you craft your prompts right, you get a response. But then there's a problem with prompt engineering. No matter how well you create your prompt, if your system does not have access to data that you are requesting for, definitely you will not have the right answer. If your system does not know the context of your question or what you are asking, it will be giving you a response that does not relate to that. And then people come with the idea of, oh, what about if you think of RAG, you have a set of data somewhere that your LLM can access, and then before providing you a response, and then we have that. Some people say, oh, instead of me using RAG, I can just fine tuning my model. Fine tuning is when you put your data on top of an AI model. The reason why I have to say this is because I'm not coming back to fine tuning, but I'm coming back to RAG. Okay, so you have a base model, say ChatGPT or say GPT-4 as a model, and then you come with your data and put your data on top of it. You train it on your own personal data. That, oh, this thing does not know about me before, and I have my data set. I put it to GPT-4, and then he knows about it because I just introduced it to my data. But then that is not safe for many reasons, and people say, oh, RAG is the best, RAG is the way. And that is why we'll be talking about RAG. Okay, so that's the end of my chapter one. I'm moving to my chapter two. Hope we are following. I need to get a confirmation. Is anybody following? Is anybody learning? I'm back on the screen. Oh, okay, nice. Okay, moving on to our chapter two, talking about retrieval augmented reality. RAG comes with the aims of improving the response that we get from LLMs. Take, for instance, Gemini. If you remember the black box that I showed us in the beginning, that model, mathematical model. So, models like that, RAG comes to add something to it to provide contextual and relevant information for our model. Okay, how does it work? If you look at diagram on the right, we can see that a user come with a prompt to a particular LLM system, in this case, Gemini. Okay, because we're at Google event. Somebody come to Gemini and puts their prompt expecting a response. Before Gemini give you a response, it will go to a set of data that we kept somewhere for this LLM to access. And then the LLM will now translate your request, your query, and then extract something that is related to your query inside the data that we provided, and then transfer it back to LLM model. And this LLM will now give you a response, and you now be like, oh, this is exactly what I'm asking. Okay, so that's basically the idea of RAG. You will have a set of data that is specific for you or for your use case. And then when somebody use the LLM, they are not getting a response that LLM is being trained on in the base of itself or the base model, but then it will be using the data that you kept somewhere to be able to get an accurate result for you as a response at the end of the day. Okay, we'll see more of this, but then that's a basic overview of it. Your data, in this case, you are not using your own particular data to train LLM. You are not doing that. What you are doing is you are keeping your data somewhere, but you are providing a layer that can extract facts and whatever things you need from your data to the LLM, and then providing you the right response, very accurate for you. And then, uh, so when we talk of why you should care about RAG and was RAG bring into your system. Number one thing is it augments your base model. It helps you to augment your base model. That's the first thing. So your data, oh, I said date. I wanted to say data. Sorry about that. That's a typo. Okay, so the data that you provide, okay, this your data here that you provide here, it helps you to augment the base model that that particular LLM model is being trained on. Okay, okay, so that's the first thing. The second thing is that it helps you to combat hallucination. I talk about hallucination, getting wrong response from LLM because they don't have access to certain data. But for your own case, you have access to a particular data, a particular fact, a particular context that your LLM can access to get some facts before providing a response. So it helps you to combat hallucination. It's explainable. It can with that your LLM can say, oh, I got this response I'm giving you from this chapter of the book that you provided as your fact or as your data source, something like that, and something of such nature. You get citation, you get references that you can trace. So it's explainable. Okay. I don't know. If you do AI, they will tell you best thing to do is do explainable AI. AI that can be traced, a traceable AI, and all of those stuff. The second thing is it's private. Remember, you are not putting your model on top of the model, the LLM model. Your data is being put somewhere, and the LLM is going there to get facts. Not that you are putting your data on top of the LLM, like fine tuning. That's different between fine tuning and RAG. For the fine tuning, you put your data inside the LLM to use it to train it. But in this RAG case, you have your data somewhere and your LLM is just going there to get facts and then using it to process whatever thing they want to process. So it's private to you. Your data is safe and secure wherever place you put it, and it's inexpensive. You don't need to have a lot of resources to train any AI model. You don't need that. All you need to do is just find a way to store your data, and then you get to get things out of your data at the end of the day. And last thing that I want to talk about today is access control. Because you are providing a layer, you have control over your data in the sense that if your company has different levels, and then you talk you when say HR search for something using the LLM that you built or your system that you built, the RAG system that you built rather, they want to use the RAG system that you built to search for something. If you don't want them to have access to some data, you can create a layer to say, oh, if it is HR department that is using this RAG system, they should not get response like this. This fact should not get to them. Okay, so you have that access control. You can create a layer, if we call it filtering layer, to be able to filter things out and then help other people not to have access to what you don't want them to have access to. So if MD, let's say the general manager, decided to search for something, the response they will get, the fact they will get from the document will be different from this fact and HR that search for same thing we get. That's what we call an access control. You have power over that. We'll see some of those stuff in action when we do them. Some use cases of RAG is that if you want to create a question and answer system, okay, one of the example that we do in the demo is question and answer system, a system that you can go to ask question about something, and then that's a perfect use case of a RAG. You provide your documents, you save it somewhere, and then LLM will go there to get it, to get the facts based on what the user is asking, and then it can get you something that you want. Second thing is AI assistant. If you want to create an assistance system, something that is specific for you, something that is peculiar to you, RAG is the best thing to do. It will go ahead to extract facts from your data that you are providing, that you are putting somewhere, and then give you a response. And if you are doing a kind of research tool, you are building a research tool, or you want to use AI as your research assistant, yeah, RAG is the right thing. You don't necessarily need to put your data on top of LLM or fine-tuning an LLM model. What you need to do is to provide a place to put your data and connect your base model to be able to access for facts from that. So those are three use cases I can think of when I was doing this slide. So there are many more things that we can find from other tools or other resources that we'll be sharing later. Okay, so this is a typical flow of how a rack system will look like. Okay, I don't know, maybe we can read it, but it's a little bit tiny. So I will try my best to read it over here. Okay, if you look at this, at the bottom of the flow, you see a box. What we put there is enterprise data source. Okay, be it data that you store in your S3 buckets, data that you store in your Google storage, Google Cloud storage, data that you store in Snowflakes, Notion, or whatever place that you're using, even from your Jira or your Salesforce uh, platform, wherever place you're putting it. Okay, so then you convert this data into documents. What we mean by document is that you divide your data into different chunks. Okay, say I want to documenting this is Taurash, for instance. We have to convert it into different chunks, word by word, divide them into words. That's what we mean. I will pick this as one word, I will pick is as one word, and pick Taurash as another word. So dividing them into three different chunks, that single sentence, this is Taurash, it's what we call documenting and chunking. That is a very crucial process that we need to do when we are creating our rack system. And then after we've been able to chunk it into different chunks or words, okay, so we now need to save it somewhere. We embed it. Embedding means we convert it to numbers. Okay, so when we need to convert it to numbers and save these embeddings inside a vector database. There are thousands of vector database out there. Okay, so if you just want to try how things work on your local machine, the best advice is to spin up a Docker container using contract. Contract is very simple to use, and then spin up a Docker container. You have a vector database that you can put things in. But in this demo, we'll be doing live. We'll be using BigQuery from Google, and then we'll see how we can use that as vector database and how things work together. Okay, so we pick our embeddings, we save it into vector database, and then our system will use that to create a prompt, attaching it to what user input from this beginning. So if you look at this green line, the user inputting something into this model, but then it's not going directly to this system unless we have our data source, and then we embed it before and put it in the vector database. Wherever user is coming with will be embedded as well, turn to chunks and embed it, and then we push it to the vector database, and then comparison occur. We construct a perfect prompt. Then that perfect prompt constructed will be passed to the LLM before we can get our response. So we can see that this is different from just putting your query into an LLM and get a response. So this layer of retrieval is what we refer to as the RAG part of things. So you have to come with your data, you embed it, you keep it in vector database, and then when a user wants to use your RAG, they provide their query is being embedded, go to the vector database that you have, another or a perfect prompt is being recreated, and then it's being passed to the generative model that you are using, in this case, Gemini, and then you get a perfect response from that. So that's a basic overview or overall view of LLM, or I mean RAG, Retrieval Augmented Generation. Does that make sense to us? Let me take a moment to ask at this point as well. Okay, cool. Thank you. Hope I'm not too boring. I'm trying my best to break it since stands. Okay, so moving forward, the question now is how do we make RAG performance? How do we make it more accurate, more easy to use, and getting perfect response from it? Number one thing is to use the state of the art embedding models. in this we have I mentioned the other time that we will embed our documents and as well embed user query. So the embedding model that we are using here is a very crucial thing to take note if you want to get a well-performance uh, RAG system. So choose the right embedding models. Okay, so we have Query, we have other tools on Augmented that you can leverage on. Okay, so that's the first thing. To build a performance RAG, you need to take into account choosing a state-of-the-art embedding models. The second thing is relevancy ranking. Relevancy ranking means, okay, you provide stages, you provide your facts in stages. Okay, a user come with a query, we embed it, we push it to the vector database, we do a kind of comparison, and then we pick top three out of what the user wants. We get top three facts. That top three facts, we can re-rank it by still passing it to another stage of or another level to get a very accurate and very close response to the uh, LLM model that we are working with. Okay, so we call, we call that the ranking. So you provide a relevance to the ranking in order for you to get the best out of your RAG system. And then the last point today is hybrid search. Don't just rely on a single search method, leverage on multiple, and then these three, if you put these three things into action, you definitely be able to get a response for your uh I wanted to share thing, but then um let me do the demo and then we can go ahead and do the two together. Stop sharing for a while. And I want to share this. Okay, so this is a system that will help us to understand a RAG. 1 second. Yeah, am I sharing it? Okay, so this is a system that will help us to understand RAG. Okay, so we decided to design this system to be. We want this page to serve as our embedding database or our vector database rather, where we can put a particular details about ourselves. So this is an question and answer model. Okay, and what it does is to be able to answer questions based on what user has. Okay, say I say company companies at EGBE, for instance. The companies at EGBE, I don't know what this one will produce, but then let's try it. Say, okay, ask me anything about, okay, it has stored what I did last. I got, okay, I know what that's. Okay, so the way this particular one works is I decided to make this like a database in the sense that I store whatever thing you put here into the uh, local storage, and then just to have a view, to let you have a view of how uh, rags work. That's the idea. Companies in EGBE. Okay, so I decided to, I think it has should have clear. Okay, so now I do not have anything in this place. So this is serving as our vector database. We did not have anything at this point. And then I come to ask question here. I will still use the same question. Companies in EGBE. If you cannot see my screen, please, you can let me know so that I can zoom in, zoom out, all kind of stuff. Okay, so I type in companies in EGBE. Okay, so and then I press send. And then I get, oh, I'm ready. I can help you information about companies in EGBE. To give you best information, could you tell me So if you go to ChatGPT to ask this type of question or Gemini, this is kind of response that you get. Okay, because there's no context to the question that you're asking. So it's be like, what kind of information are you looking for and all kind of stuff. But then I created must not slide. I created a document which specifically for a profile for a company that does not exist, but then I decided to say it exists, and the headquarters is in EGBE, Nigeria. Okay, so now I provided that document. So this is document, this kind of document that you provide from that enterprise layer. Remember that slide that I showed us the other time. So you provide your data, you embed it and put it in vector database. At this point, these are our documents that we are using in this context. Okay, so these different details about a company that does not exist in EGBE, but we decided to say it's in EGBE. Okay, so now if I come to say companies in EGBE, for instance, it should be able to pick up, oh my God, what am I type? It should be able to pick up that, oh, based on data that I have access to, there is EcoVisa. EcoVisa is that name of that company that is based in EGBE, and the headquarters is in EGBE, Nigeria. What they do is this climate, their climate startup, they use AI to do this. All this is it was able, I mean, the system was able to generate a perfect response because we were able to provide another set of documents and perform all those RAG methodology on it. Does this sound like something that makes sense to anybody? Or do I need to retake how this thing works? Okay, so that's the basic. Thank you for that. That's the basic demo that I want to show us. You can provide, you can, if your data source is an image, you can provide it using this system. If you want to test this out, I can share the link to the GitHub repo. You can clone just a Next.js app, and then you can interact with it and see how things works. But then this is just like a basic view of how RAG work. You provide a context or a data, and then all the embeddings happens, store it in a vector database. In this space, we are not using vector database. We just have to put it somewhere in local storage, and then we provide access to it uh, by just connecting whatever we have here to this system. So that is the first demo that I want to show us. So let's go a bit technical. But before I do that, I would like to ask who is interested in. I don't want to be alone. Nobody's facing out. Okay, one person, two. All right, thank you. Thank you. Sorry for disturbing you. All right, so let me take us through a more technical demo. Uh, so in this case, we will be creating RAG leveraging on uh, BigQuery. Let me share I'll be sharing my Google Cloud platform. That's what I'm doing next. Loading. Okay, we have it up. Mm, This one is understand. I'm trying to set up, get it up. Give me 10 seconds. Yeah, yeah. The window. Why am I not getting the window? It's like I'll be sharing my entire screen because it's not getting what I want. Sorry. Opening a new tab. Don't have this set up. I'm finding it difficult sharing my screen, that's why. Um, I decided to open it in another window, but then it's not okay. I think I have it up now. Go back here. Yeah, dashboard. Okay. I believe you can see my screen now. Start sharing here. Okay, so that's my Google Cloud platform page. And it's not a real account. It's an account that I got from QuickCloud. I can share a link to that QuickCloud. Everybody can take it as well. If you need credit to take it, I can get it for you. So let's go through it. Okay, so the first thing that we need to do to be able to do anything here is to be able to access our BigQuery. Okay, so I'll click on this BigQuery. I hope you can see it. Not too small. If I need to zoom, please let me know. So I'll click on this BigQuery tab here. Okay, so remember I talked about needing a vector database. We need a database. We need where to put our details. Okay, so if you come here, you click on this add data, and then after clicking the add data, you search for Fattest AI. Okay, so I'll pick this response I got by typing Fattest AI here. Feel free to cut me if you cannot see anything or you don't understand any step I'm taking place. Okay, so I'll click on this Fattest AI. I'll click on this option, and then I can create an ID for this. So you can say embedding, what can we call it? Say embedding calls, for instance. Okay, so and then I'll click on create connection. I'll go to connection. Then all I need to get from here is this particular service account ID. Okay, so if you create it, to tell you to go to the connection, you click on it. If you miss that, you can come back to your Explorer and open up you will find your project like this. And then you can extend this and then come to external and then click it. Then you'll be able to get this particular right hand side. And then you'll be able to copy this particular uh, service account. Does that make sense to us? Or is anybody following up to that level? Okay, so moving on, we need to enable API service for our BigQuery. Okay, so we go to this particular page, and then I'll search for one I. Okay, I'll search for Vertex AI API. So I'll click on this. I search for Vertex AI and it brought up a suggestion that Vertex AI API. And then I will enable this. Okay. Why that is enabling, I need to grant a row to this particular BigQuery that we just created. Okay, so that's what I'll be doing next, giving permissions to our BigQuery. Okay, this one has done. So I'll go back to my home page, go to this I am. Okay, let it load. All I need is to, after clicking on I am from the side button here, if you miss that, this is what I clicked, this particular one at my left hand side. I click this and I come here. I will click on grant access and then I will paste that service ID that I copied the other time. You know, when we created the BigQuery connection, we added, we copied the service account. So that's what I would do, and that's what I just did. And I will click on save. If saying something, make sure of it. Okay, let's add some row. Say Fattest AI owner, something like that. Fattest AI is let's find out. Okay, fattest AI user, and then we can add another one. We need to access to that. Then big query data, big query, what's searching? Big query, big query data owner. Okay, so these are the two assets that we need to provide for our fattest model to be able to access in order for us to be able to use Gemini. That's the point of all these things that we are doing here. So we are keeping our data in BigQuery, and then we need our Gemini model from fattest. That's all what we are trying to do here. Okay, it's as simple as that. So those are the most technical things to do, and then we can start to run our query to generate embeddings. Okay, so the first thing is for us to connect to our embedding model. I talked about embedding the other time I was discussing the best way to go. So I'll go back to my BigQuery tab and then decide to run. So say BigQuery. Okay, I should be able to find it here. BigQuery. Hope I'm not too technical. That's one of my fear. So I'll go to this particular project that we created the other time. I can come to this playground here and I can start to run my query. Okay, so the first thing I want to do here is to be able to connect to, I don't know if you can see that query, but then I will share the link to, uh, what's it called? The link to what you can use to interact with this or the quick lab. So basic thing is we want to create an embedding model. So I will run this. Not found dataset quick lab customer review was not found. Oh, I'm missing something. Let me get that up again. Hmm. So what I'm missing at the moment is to create a data set for this. So let's do that. Open this, come here, create a data set, and then I'll put that customer review, which is complaining here that it cannot find. And then I'll click on create. And then if you run this now, yes, we get that one, and we can go to that data set. So the data has been created, the model has been created, and then we have access to that. Okay, so you can preview it and all, but then because of my time, I think I have less than 10 minutes. So I need to rush through that. Okay, so the next thing I'll be doing is to load my data into the database I just created. Remember, the code we just run now create a model for us, like creating a database for us where we can use to create our embeddings or save our embedding models. So if you look at this particular URL, it's a CSV file that contains certain data. So I will show us the data very soon. It's on Google Cloud storage. So if you run this, it will download this particular data set for us, and then we can have access to it here. So that is what we'll be using our data source here. So it has done that. So I can go to table. I think I can close this tab so that we have enough space. Okay, so this is how our table look like. But then if I go to preview, we have access to this data. So this data is a list of reviews from customers. Okay, we gather reviews. Say we are and what do we call ourselves? A platform where people buy something and they leave review. So this is the list of review that customer has left for our product. So that is the content of that particular, what's it called? The content of the particular documents or data that we are providing as a document to serve as a layer to our LLM. Okay, so we've gotten that data and then we've gotten it to save into a database. What we need to do next now is to be able to create embeddings out of this. We need to create embeddings out of it. So I'll come here to run another query, just your SQL query. So you can be doing this with codes. I just decided to use SQL as my code because of my time. Okay, so I'll go to my data to the table we just created, and then if I preview it, you will see that the data will have been embedded to that's turned to numbers. This is what we say when we are talking about embedding. This is what we are saying. So all the data, the review that we just saw now, has been turned into numbers. So that's what we refer to as embedding. We've been able to embed it, and then the customer, our system can leverage on getting that up and then use it for whatever thing they want to use it for. Okay. So the next thing now is to uh, add what's it called? Embedding. For us to add an embedding, what should we add first? For us to ask our embedding model, the type of model we want to use for our embedding. So at this point, we'll be going for this cosine rule. So if I run this, you may not see a lot of changes, but then I can try out this and see what the results that will be provided. So I can decide to search my vector space to retrieve similar stuff. So say I want to search for services. So the best command for me to search for services in this particular, let me see if I can expand this. Oh my God. Okay, let me just show you. I'm trying to select, if you're writing SQL, I'm trying to search for every word that has select from the document that we have embedded. That's what we are trying to do now. We've embedded a particular document, the document that shows us. But now from that document, I want to search for a word that has service. So you can see that I'm working on the generate embedding model that we just used just now. So if I run this particular code, it will run, take time to run, and then it will find every response or everything that has services in the document. So these are the things that have services in this document that we provided. So somebody said bad services. This service was great. Are you trying to speak? Okay. So I'm rounding up soon. So if that's what you want to tell me. Okay. So we've been able to get data up. I mean, certain things from the uh, data that we embedded into our vector database. That's what we just did now. So by running this particular query, so we've been able to access what we have in our embedding vector database. Okay. So let's do this last two steps that we need to do and then get out of this place. Okay. So let's now say this data that we have, this data that we have, we want to we want our Gemini Flash or whatever Gemini model that we want to use to access it. That's what we want to do now. So let me get that command to run. Okay, so we have this particular, and then we are using Gemini 2.5 Flash for this particular one. And then you remember we have this connection that we created the other time. So if I run this now, what I'm doing is trying to connect to my Gemini, and then I'm using my Gemini 2.0 Flash. With that, I can now leverage on the data that I have to get a response. Say my my question or what I want to ask this LLM model in this regard is to summarize what customers think about our service. Okay, that's what I want to ask this particular RAG model or RAG system that we just built. So we want to learn from what customers are saying about our service. We want it to summarize it for us. Before, if you just go to Gemini and you type summarize what customer are saying about my service, you will get no response. As regards the demo that I showed us the other time, that we just ask companies in EGBE and it's telling us to give more context or what you want. Same here, it will leverage on the uh, vector database that we create to get more facts and know more about our system. So if I run this now, we now look for what Gemini will give us as a response. And Gemini is giving us this. Let me see if I can extend this guy. So, So it's telling us on this point. He said customers generally have a positive view. So comparing all the data, all the responses, or all the feedback that we got from customer in the data that we provided, it's telling us customer. This is coming from Gemini now. That customers generally have a positive view of the service, praising its speed and all of that. These are what customers are saying based on our uh, the document that we provided. So this is not only coming from Gemini, it's coming from using the data that we provided to be able to generate the accurate response to what we are asking. And then at the end of the day, we get perfect response for our system. And this is the second demo. It may be a little bit tough to follow or difficult for us to get. But then what I did is to, I guess the organizer as well recorded this session. You can share it if you want to try it on your own. I did a recording on my hand as well. If you want to get that one too. So let's go back to our slide and then call it a day from here. Stop sharing for the last time before they chase you out of here. Okay, we've done the demo one and then we've done the demo two. Okay, so these are some of the resources that you can check out if you want to learn prompt engineering, if you want to read more about RAG and a lot of things around that. Before I leave, I would like to talk about Gemini contest. Gemini decided to provide a contest for you. They say, oh, if you are not looking into bigger data, you can leverage on Gemini contest to be able to do what RAG is doing for you. Okay, so you may want to read as well about that. I will be updating this slide before sharing it. I will add links to that as well. Okay, so thank you for listening to me. Yeah, this QR code should lead you to my YouTube channel where we talk about getting started in tech, open source, DevOps, and all. So if you want to check it out, you can use the link you can see or scan the QR code. Anyone that works for you. So with that, I would like to appreciate you for listening to me. Thank you so much for participating. Is anybody there from the main room? Oh, okay. Okay, no problem then. So do they have any question or we can call it a day from here? Okay. Yeah. Okay. So that means they could not follow from the last part of slide. Or where did they get lost or something like that? Oh, okay. All right. It's okay. So that's the end of the session here on YouTube. Thank you for participating. See you all next time. Bye.